In the previous class, we have done the Dalton's theory. Do you remember? Dalton's atomic theory. Yes. Yes. And in this theory, we learned 5 points, or you can say that we learned 5 postulates. First is matter consists of indivisible atoms. Atoms are which we cannot further divide. Second postulate says that all the atoms have a given chemical element are identical in mass. That means in a particular atom, the chemical element will be identical in that entire element. Third point says that different chemical elements have different kind of atom. That means every element will not have the same kind of atom. Atom will change. The atomic mass will change. Fourth postulate tells us that it is indestructible. Indestructible, that means you cannot destroy it completely. Okay. And it retains their identity in their chemical reactions. That means kitna bhi chota particle rahega, kitna bhi chota atom rahega, it is going to have its identity. ऐसा नहीं है that if you reduce it down, that the identity will be reduced or the characteristic will be reduced. It is not like that. And point number 5 or postulate number 5 will tell you that the formation of a compound from its element occurs through the combination of atoms. Any compound that is formed is with the combination of atoms of unlike elements. If it is same, if the atom is of the same element, then will I call it a compound? No. Compound is going to be of two different atoms of two different elements. Do you get me? Then you call it a compound. So this is what we had done in the last class. And we also learned that the Dalton's fourth postulate talks about the law of conservation of mass. Because law of conservation of mass, what does it teaches you? That atoms cannot be destructed. Okay. That means the number of atoms in a reactant should be equal to the number of atoms in the product. Am I right?
It is the total masses of all the reactants.
Yes, it has to be equal. That means your left hand side should be equal to your right hand side. This is what it means, law of conservation of mass. It cannot escape somewhere. It has to be there. Okay. And the fifth postulate tells you about the law of definite proportion. Now, when I say proportion, that means there is a fixed proportion between the reactants and the products. So there is some number game is there, some proportion game is there. Is it very clear till here? Can we go ahead?
Yes.
Yes. I hope you all are doing the reading also simultaneously. You all are reading, trying to understand. And if you are not able to understand, you can ask me doubts. We also learned about carbon monoxide and carbon dioxide, where we said carbon monoxide, that means what is carbon monoxide? 1.000 gram of carbon will be there in oxygen. And carbon dioxide means the double of it will be there in 1.0000 gram of carbon. Do you understand? That means it's twice. Dioxide is 2 times. Monoxide is 1 time. But then the ratio is fixed. The ratio does not change. You can see 1.3321 grams of oxygen. We will become double if we talk about dioxide. Do you get me, bacha?
Yes.
Why do I call carbon monoxide or call carbon dioxide as compounds? Now do you understand? Because both are of different atoms, different elements.
Different atoms of different elements.
You have carbon and then you have oxygen. Monoxide means 1 part or 1 ratio of oxygen. Dioxide means twice the part or 2 times the proportion. Got it? Did we do what is an atom? Did we start doing that? No. I think we only did till here. Carbon monoxide and
We
carbon
have to
dioxide.
start from here.
We have to start 3.2.1. Okay. Now today we are going to learn about what is an atom. We actually know what is an atom. Do we know what is an atom? Smallest particle of an element which retains its chemical property. If it starts losing its chemical property, can I call it its atom? No. You're getting me? That means it has to have the properties also. That is also very important. Smallest particle and not having property cannot be called as an atom of that particular element. To be the atom of that particular element, it should show the chemical properties of that particular element. So I repeat, atom is the smallest particle of an element that retains its chemical properties. Very important definition. The next point, an atom of one element is different in size and mass from the atom of other elements. Every atom of different elements will differ from each other. They cannot be same. The size will not be same. The mass will not be same. Is it very clear? This also has to be understood. An atom of one element will be different in size and mass from the atom of the other element. These atoms were considered indivisible by Indian and Greek philosophers in the beginning, and the name atom, as mentioned earlier, came out of this basic philosophy. Atom means indivisible. But today we know that the atoms are not indivisible. They can be further broken down into smaller particles, although they lose their chemical identity in the process. Okay. See, earlier what people said, that they are smallest particle, we cannot divide them further, and they retain the chemical properties. But today we've understood that that smallest particle can also be divided, but when you divide it, it loses its chemical identity. So this is one advanced thing that we have learned now. From then and now, the difference is that an atom can also be further divided. Is it very clear? But in that process, what happens? The identity is lost. The chemical identity is lost. Is it very clear? But in spite of all these developments, we say that atom still remains a building block of the matter. That means that matter will be made only out of these small particles, that is atom. Is it very clear? The concept of atom is understood. Barira, Pranav, Sharia,
Yes.
Sufyan.
Yes, ma'am.
Yes, ma'am.
Okay. Now we are going to move to 3.2.2. That is, what is the size of the atom? How much should it be to be called as an atom? Atoms are very small. They are smaller than anything that we can imagine or compare. In order to have a feeling of size of an atom, you can consider this example. 1 teaspoon of water. 1 teaspoon of water, which is about 1 ml, contains about 3 times as many atoms, 3 times as Atlantic Ocean contains teaspoons of water. My God. Can you understand what it means? It is telling you 1 teaspoon of water, which is just 1 ml, will contain 3 times as many as atoms an Atlantic Ocean contains. Teaspoon of water. Teaspoon of water. If you start measuring Atlantic Ocean with teaspoon of water, how many teaspoons will be required? We can't even count. So many. Okay. और उसका भी 3 times पकड़ लो. That many atoms will be there present in that 1 small teaspoon of water. In that 1 ml of water. Okay. So also more than millions of atoms when stacked would make a layer barely as thick as the sheet of a paper. That means आपका पेपर कितना थिक होता है जिस पे आप राइटिंग करते हो? Very thick? No, it's just normal. It's that okay. But if you call that thick sheet of paper, in that thick sheet of paper, millions of atoms will have to be sacked together. Then it will become that much thickness as the paper you have in your hand. Getting me? So you can imagine how small that atom will be to be stacked up in millions to become that thick paper. Atoms of different elements not only differ in mass as proposed by Dalton, but they also differ in size. Different element का atom है तो उसका size भी different रहेगा, उसका mass भी different रहेगा. This is very, very important to know. Now the question is, why should we bother for the size, mass, and other properties of atom? The reason is simple. Every matter that we see around is made up of atoms. Is it rectangular? Is it circular? It is spherical? It is difficult to imagine the real shape of atom. But for all practical purposes, it is taken as a spherical in size, shape. Okay? And that is why whenever we talk about its radius of that particular atom, because we take it to be spherical in shape. Do you understand? यहाँ पे size नहीं आना चाहिए. The word here should be shape.
Where, teacher? Specifical in shape.
Yeah.
Sorry, spherical in shape.
Yeah, spherical in shape. It cannot be spherical in size. Now, since size is extremely small and indivisible to our eyes, we adopt a scale of nanometer. Okay, and 1 nanometer. This we have learned, if you remember, the chapter 1 that we did. One nanometer is equal to 10 raised to minus 9 m. Do you all remember Barira, Sharia?
Yeah.
Yeah. So 1 nanometer. We take it at that scale. Is this much part understood?
Yes.
Can I go ahead? Any doubt in this much part?
No.
Okay. Now they say you can have a feeling of its size from the following tables. Okay. A radius in meters. If it is 10 raised to minus 10, then you will call it an atom of an hydrogen. So you can get the size of hydrogen. 10 raised to minus 10 is the size of the atom of an hydrogen. 10 raised to minus 4, okay, is the grain of the sand. You're getting me? 10 raised to minus 1, watermelon. You're getting the size? When raised to minus is increasing, that means it's becoming smaller and smaller. Am I right? Are you getting me, beta?
Yes.
And 0.2 multiplied by 10 raised to minus 1 is the size of a cricket ball. So now you can understand and you can evaluate. You cannot see atoms with your naked eyes, but by using modern techniques, we can now produce magnified image of surface of elements showing atoms. The technique is known as the scanning tunneling microscopy. You have to remember this, huh? Very important. Name the technique by which you can see the atoms, okay, using modern technique or technology. The technique is called as the scanning tunneling microscopy, STM. With the help of STM, we are able to see the atoms on the surface of that particular element. like how you can see in this figure 3.2. Are you all able to see the figure 3.2? This is an image
Yes, ma'am.
of copper surface. Okay, see how many atoms you can see, these spherical atoms. Can you see these round balls?
Yes.
These are atoms. I hope you can see them. Yes. Image of copper surface by STM technique. Atom can be seen in the magnified image of the surface. Okay. Can we go ahead?
Yes.
Now we are going to learn. Now we just saw the size. Now we are going to learn about the mass. Dalton gave the concept of atomic mass. According to him, atoms of the same element have same atomic mass, but atoms of different elements have different atomic mass. What is mass? Actually, how can you compare mass with, or with what can you compare it with? Can we say the weight of it? Yes or no?
Yes.
Yes.
Yes. Since Dalton could not weigh individual atoms, he measured relative mass of the element required to form a compound. He said, Abhi, each atom he cannot weigh. So what he did, when they got mixed together as a compound and he understood the proportion, then he started coming up with relative atomic mass. Comparison. With comparison, he got the atomic mass. For example, we can determine by experiment that 1.0000 gram of hydrogen gas reacts with 7.9367 grams of oxygen to form water. If we know the formula of water, we can easily determine the mass of the oxygen atom relative to that of the hydrogen atom. You understand? Now he cannot tell how much the hydrogen atom is weighing, or cannot tell how much an oxygen atom can weigh. But in relation to them, he can say that for every 1 gram of hydrogen, I will require this much gram of oxygen. And in that way, you can come to know the mass. You're getting me?
Yes.
Dalton did not have a way of determining the proportion of atoms of each element forming water during those days. During those days, it was not possible for him to tell you the exact proportion. He assumed the simplest possibility that atoms of oxygen and hydrogen were equal in number. Initially, he thought they were equal in number. From this assumption, it would follow that the oxygen atom would have the mass of 7.9367 times of hydrogen. Getting it? He thought they were equal. And that is the reason why he thought that the oxygen atom would have the mass that was 7.9367 times of hydrogen atom. This in fact was not correct. We now know that we now know that in water number of hydrogen atoms is twice the number of oxygen atoms. Yes or no? That is why we call it H2O. H2O means what? Hydrogen ka 2 atom, oxygen ka 1 atom. Yes or no? Therefore, relative mass of the oxygen atom must be 2 times 7.9367. That is 15.873 times of hydrogen atom. So if you want to know the measurement with that, now where we have made development and understood that it is going to be twice, he understood that the oxygen atom must be double that of the hydrogen. Getting me? We're
Yeah.
talking about relative mass. After Dalton, relative atomic mass of several elements were determined. based on the hydrogen scale. क्योंकि एक मालूम था, and then on the relative or comparing with it, he got to know the mass of others. And then later on, this came to be known as hydrogen base scale because it was based on hydrogen. Hydrogen base scale was then replaced by a scale based on oxygen because oxygen was more reactive and formed more compounds as compared to hydrogen. Now, first what happened? They tried to find it out with the help of a compound water, where they tried to see hydrogen atoms and oxygen atoms. So they made a scale based on the hydrogen, taking hydrogen and comparing it with hydrogen. But later what happened, the scientists, they found out that more than hydrogen, oxygen is more reactive and oxygen is forming more compounds. So why not make a scale which is based on oxygen so that we can have atomic mass of more elements. In 1961, C12 or 12, you can say 12C6 atomic mass scale was adopted. And this scale depends on the measurement of atomic mass by an instrument called as mass spectrometer. C12 or 12C6. You getting me? 12C6 atomic mass scale was adopted. And this scale came to be known as mass spectrometer. And mass spectrometer, invented early in 20th century, allows us to determine the atomic masses precisely. Now we came to know how we can get it properly. The masses of the atoms are obtained by comparison with C12 atomic mass scale. In fact, C12 is an isotope which has been taken as a standard and arbitrarily assigned as a mass of exactly 12 atomic mass units. C12 isotope is being chosen as the standard form. Okay. And it is assigned as a mass of exactly 12 atomic mass units, which means one atomic mass unit, which is known as mu, equals to exactly 1/12 of mass of carbon-12 atom. One atomic mass unit. We had to make a unit, a fixed unit, a standard unit. So then that standard unit came to be known as mu. Mu means atomic mass unit. It was fixed at equal to 1/12 of mass of carbon. Okay. 1/12 of mass of carbon, that means 12 atoms. Atomic mass unit is nowadays written as unified mass unit and it is denoted by U. If you remember, I had spoken about mu in the first chapter also when we did units. Do you remember? Sufyan, Barira, Sharia, y'all were there
No,
for the
ma'am.
first chapter.
Yes.
Yes, I had
Yes.
spoken about mu, where I told you that U is written a little differently. I had shown you the picture of mu also. You want to see it again so that you can remember? See, this is how it looks. This U, can you see?
Yes, ma'am.
Actually, I remember I had showed it to you people. Not able to get it now. It is like how it is written in italics, no? A little curved one. The U, one side is curved. So, anyways. Okay. Have you understood till here?
Yes.
Can I go ahead? Barira,
Yes,
are you
ma'am.
understanding what I'm doing with you?
Yeah.
See, if you are not understanding, you're supposed to ask, because otherwise it's going to be very difficult for you to do it next year. So many chapters are there, whether it is maths or science. To cover it will be very difficult if you don't understand everything. You can't leave it for the next year. The relative atomic mass of an element expressed in atomic mass unit is called as its atomic weight. So for example, if they ask you to define atomic weight, what is that? Atomic weight is nothing but the relative atomic mass of an element expressed in mu, expressed in U. Nowadays, we are using atomic mass in the place of atomic weight. Further, you have seen that the Dalton proposed that the masses of the elements are equal. But later on, it was found out that all the atoms of the naturally occurring elements are not of the same mass. The mass is going to change of different elements. We shall study about such atoms in the following section. Atomic masses that we generally use in our reaction or the chemical calculations are known as the average atomic masses, which depend upon the relative abundance of the isotopes. See, you cannot take the exact atomic mass of that particular atom. So what we usually do that, जहां तक आप उसको divide कर रहे हो और वो atom बना रहे हो, तो उसका average atomic mass कितना है? And we take that number as the atomic mass. Do you get me right? Okay. Now we are learning about isotopes and atomic mass. Dalton considered an atom as an indivisible part. You cannot divide it further. Later research has proved that an atom consists of several fundamental particles. And those fundamental particles are, an atom consists of electrons, protons, and neutrons. And electron is nothing but a negatively charged part. Okay. Proton is a positively charged particle. Okay. And neutron is neutral, which means it has the number of electrons and the protons is in an element is equal. Since the charge of an
In the
electron,
nucleus.
yeah, it
In
is
the
neutral.
nucleus.
Pardon?
In the nucleus, it has the
Yes,
same
yes.
amount of protons and
Yes,
electrons.
yes, yes, yes. Electrons, protons, and neutrons. Electrons are negative, protons are positive. Okay. And we can say that the number of electrons and protons are going to be equal. And because positive and negative is equal, you call that atom to be electrically neutral. Because there is no charge, no positive charge, no negative charge. Charge on an electron is equal and opposite to the charge of a proton. Okay. Protons remain in the nucleus in the center of the atoms, and the nucleus is surrounded by the negatively charged electrons. That means inside, in the nucleus, what is there? In the center of the atom, what is there? Positive charges is there. And what is it surrounded with? The nucleus is surrounded with negatively charged electrons. Do you get me? Everybody has understood the structure of an atom? An atom is an indivisible part. It has got several fundamental particles, electrons, protons, and neutrons. Electrons are negatively charged and they are on the outside of the nucleus. Okay. Protons are positively charged. They are in the nucleus, in the center of the atom. Do you get me? The number of electrons and protons are equal, and that is the reason why we say that an atom is electrically neutral. Have you understood well till here?
Yes.
Now, when I say one proton, that means one neutron, one electron bhi hoga. Because we know proton and electron are going to be equal in number. If I say one proton, you can see one negatively charged outside. Can you see this? If I say one proton, that means one electron is also going to be there. And electron is negatively charged and it is outside. It is surrounded to the nucleus. If I talk about 6 protons, that means 6 electrons are also going to be there. So you can see them. 1, 2, and the rest 4 are on the other orbit. 1, 2, 3, and 4. Can you see this?
But sometimes they are different, no teacher, for some elements.
Yeah, this 6 proton one is the carbon one. The first one is the hydrogen one. And C is oxygen. 8 protons. If 8 protons, that means how many electrons? 8 electrons.
8 electrons.
Okay. In the first orbit, you can see it cannot occupy more than 2. That is why you can see in 6 proton wala also you can see 2 in the innermost orbit, in the first orbit. And same you can see here in the oxygen also. In the inner orbit, you can have only 2 electrons. And the rest are occupied in the second one. The 6 are occupied in the second one. Can you see that? Have you understood well till here?
Yes.
This figure 3.3 is the arrangement of electrons around the nucleus. The first one is of hydrogen, 1 proton, 1 electron. The second one is about carbon, 6 proton, 6 electron. And the third one is 8 proton, 8 electron. Can you see that? The number of protons in the nucleus is known as the atomic number, and it is denoted by Z. Please remember this very well. For example, if there are 8 protons in the oxygen nucleus, 6 protons in the carbon nucleus, and 1 proton in the hydrogen nucleus, then we can say that the atomic number of oxygen, carbon, and hydrogen are 8, 6, and 1 respectively. Do you understand? Atomic number of oxygen will be 8, atomic number of carbon will be 6, atomic number of hydrogen will be 1, because atomic number means number of protons and it is denoted by Z. Clear till here?
Yes.
Any doubts?
No.
Now there are also neutral particles in the nucleus. There are also neutral particles in the nucleus and they are called as neutrons. Neutrons are neutral. As I told you, protons are positive, electrons are negative, and neutrons are neutral. Mass of a proton and of a neutron is nearly the same. And total mass of the nucleus is equal to mass of protons and mass of neutrons. Get me? Is it clear till here?
Yes.
Total number of protons and neutrons can be called as the mass number, the atomic mass. Okay. Now by convection, atomic number is written at the bottom of the left corner of the symbol of the atom of a particular element, and the mass number is written on the top left. Okay. Top left, bottom left. What is written in the bottom? Tell me. Atomic number. Atomic number. And what is written on the top? Atomic mass number. For example, if I talk about 12C6, then it indicates there are total of 12 particles in the nucleus. Okay. 6 are protons. Do you understand? If 12 is the atomic number, that means 12 minus 6. 6 are going to be neutrons. Do you understand what I speak, beta? If we talk about 12C6, 12 is coming first. And the one that comes on the top is the mass. Mass means you protons and neutrons together. Okay. In the bottom, what is written is only the number of protons is written. Okay. You're getting me, na?
Yes, teacher.
Yes. So that means 12 is all together. 6 is the protons. So if you need to find the neutrons, you will minus 6 from 12. Now look at 1608. 8 is going to be the protons. 16 is going to be the nucleons. Nucleons means protons plus neutrons. Proton plus neutron. What is it going to be? Mass. So on the top, you are going to write the atomic mass number, and in the bottom, you are going to write the atomic number. Okay. Now, since atom is electrically neutral, oxygen has 8 protons and 8 neutrons. Further, atomic number differentiates the atom of one element from the other. Is it very clear?
Yeah. Teacher, what if the atomic mass number, that is the in the above, if it is written an odd number, if it is an odd number,
See, now
then you will
that
not
we,
have same. Yeah.
yeah. So that means then it will be either a negatively charged particle, or if you have more of the positively charged particle, that means if you have more of proton, then it will be a positively charged particle. Okay, that also we are going to learn. For now, you just try to understand what are, I will teach you that also. We will learn it further. Yeah, in this chapter only we will do. Since atom is electrically neutral, okay, and that is why you have equal. If it is going to be negative, then what? If it is going to be positive, then what? We will learn about it. An element may be defined as a substance where all the atoms have the same atomic number. Then you call that an element. An element may be defined as a substance which has all the atoms of the same atomic number. If the atomic number changes, then you can't call it to be an element. Getting it? Atoms of an element that have the same atomic number Z but different mass numbers are known as isotopes. If the number changes, then you call it to be an isotope. You don't call it to be an element. Getting it? Like for example, look here. 1608, 1708, 1808. That means what are they trying to tell you? 8 is the proton. नीचे का जो नंबर है वो क्या है? Atomic number है. Correct है? Correct?
Yeah.
And the number that is on the top is what? The mass. So if the mass changes, the element is going to remain the same, but you won't call that to be an element. You will say it is an isotope of oxygen because it does not have equal number of protons and neutrons. Getting it?
Yes.
So this is all about isotopes. So what you need to revise at home is, I will teach you all these sums further. You don't have to do the sums at all. Example 3.1, from 3.1, I will do it in the next class. Okay, that is why I'm not going very much in detail in this paragraph. I've only explained to you the difference of an element and an isotope. Element will have same atomic number, and atoms of the element that have the same atomic number but the mass number is different, then you'll call it an isotope. Okay, I've only explained the difference to you. The sums I will be doing in the next class. Till then, what are you going to learn is, what is an atom? What is an atomic mass number? What is an atomic number? And how are they different? What are they denoted as? All what I just did today, you're going to read and register it in your mind, so that when we are doing these numericals, you'll be able to do them with ease. Have you understood well, beta?
Yes, teacher.
Today's lecture understood? Any doubt? Or what you can do is, you can ask me doubt in the next class. Please read that much part. Try to understand. Still, if you don't understand, I will explain again. Okay? Bye-bye. Enjoy your day.
Bye, ma'am.